Go.
Hi guys, welcome back to another video from the Algebras. So last time we talked about what a vector is, how to represent it and determine its coordinates. And today we'll talk about basic operations that we can do with these vectors, such as addition, subtraction, and also multiplication with a scalar. But let's hop into it. Let's start from the first operations, the addition and subtraction. Let's draw a vector u and another vector v, here represented. In order to sum them, we just have to transpose the vector v at the end of the other vector u. The vector binding the initial point and the final one is the one representing the sum of vectors u and v. Let's do it. So we take a ruler and we can easily transpose the vector v at the end of the vector u. Here it's a bit approximate, but so we draw a 5 centimeter vector that it's equal to v, and we can bind the two vectors. This vector obtained, we can call it S, is actually the sum of v and u. In the particular case of a sum of two vectors starting from the same point, we can apply a fancy rule in order to determine their sum. Let's assume we have vectors AB and AC. In order to determine their sum, AB plus AC, we just have to draw the parallelogram ABCD and then trace the diagonal of the parallelogram binding A to D. The vector obtained corresponds to the sum AB plus AC. So let's do it. We take the same ruler and we place a point D, taking the same length AB and putting it to the point C. So here we have 16 centimeters. So we'll place our point D right here. And now we just have to connect the different points. We obtain the parallelogram ABDC, and we draw the diagonal of the parallelogram AD. And this vector, that we call it S, will exactly correspond to the sum AB plus AC. For the sum of two vectors, we have an important relation to remember, the Chasles relation. Let's have a vector AB and the vector BD, and we have that AB plus BD is actually equal to AD. From there, it is easy to determine some equalities when it comes to vectorial expressions. When we are given the coordinates of both vectors, we can simply add them one by one in order to obtain the coordinates of the vector representing their sum. Here we have an example of two vectors, u, which coordinates are 2 and 4, and v, which coordinates are -1 and 3. The vector that is equal to the sum of u and v will have the coordinates of u and the coordinates of v added. So in this case, we just have for the abscissa to add 2 and -1, and we obtain, of course, 1. And for the ordinate, we just have to add 4 and 3, and we obtain 7. For the subtraction, the process is the same. We just have to invert the sense of the vector added. In this case, we can just put a minus in front of the coordinates of the vectors v. Another basic operation is the multiplication of a vector by a real number. Graphically, we maintain the same direction of the vector and change or not its sense depending on the sign of the number multiplied. the magnitude of the vector is multiplied by a factor corresponding to the number multiplied. In this case, we have a vector u that we want to multiply by -3. How we can do it? But it's easy. We just have to draw 3 times the vector u, but as we multiply it with a negative number, we have to add it with the opposite sense. As we can see here, the vector u is added 3 times, 1, 2, 3, and we obtain this vector m that corresponds to the vector u multiplied by -3. When coordinates are given, we just have to multiply each coordinate by this number. We have here another vector u, which coordinates are 2 and 1, and the multiplication of this vector by -3 will be, for the abscissa, -3 by 2, we obtain -6, and for the ordinate, we obtain -3 times 1, that is equal to -3. And that's it. Thanks for watching. Leave us a like, hit that subscribe button, and always remember, be a wise guy, give maths a try.